C# is basically a language that is Microsoft's answer to Java, and pretty much everything that Microsoft does for application development, web development, machine learning, whatever it is, they're going to be doing it with C#. So this is a great language to learn. It's a great ecosystem. There's a lot of really neat things you can do with C#. You can make websites, you can make PC applications, you can also make Android and iOS applications. In fact, I'm looking to convert us over from using WPF to using Maui during this semester. With Maui, you can actually make an application once and deploy it to PC, iOS, and Android. So that's kind of neat. And it keeps growing. So there's a lot of neat new stuff. What is .NET? C# is the language. .NET is a collection of libraries which is used to build things. And it's Microsoft's library. If you search for .NET online, you'll see this as .NET Framework. You'll notice that it allows you to build pretty much everything we typically see used that involves a computer, except for maybe IoT, but actually, no, we've got IoT too. So we pretty much have everything. AI, game development, Internet of Things, mobile, desktop, front-end web development, back-end APIs. Pretty much Microsoft's goal with .NET is to be able to build anything. We are going to be doing mobile and desktop development, so we're kind of going down this path. And you can see here the latest thing that they're using is .NET Maui. Last time I taught this, we used WPF, but I kind of like to stay current, mostly because it might be a year or so before you get to working, and if you're working, it's better that you're kind of up to date with the latest thing. And yeah, it's a little bit challenging to look at the newest stuff sometimes. We will struggle. How many people think that programming is always just like, once you get going, you just sail along and it's just, really easy and there's never any challenges and it's simple? Yeah, pretty much no. That's not why they pay us a lot of money for this. They pay us a lot of money because things change. And one of the things that we want that makes us valuable is that we can figure things out. And so I like to model that a little bit. And so we're going to figure stuff out. We're going to play with this framework, and we will run into challenges and difficulties, and then we will overcome them, and we'll make really cool stuff. And Maui is really, really neat. The idea that you can build your code one time, and then you can get an Android app, an iOS app, and a PC app, and it's not just goofy stuff. It's like an actual, serious development platform. And allows you to customize it so you can use all the unique features of each of those platforms at the same time is really cool. Oh, and you can also build on Mac. So that's pretty amazing. And now to build on Mac, you do need to have, in order to be able to, there's a certain phase, you have to have a Mac to be able to deploy your application. So Apple still maintains control of their ecosystem that way, but as long as you have a Macintosh somewhere, like a relatively inexpensive laptop, like a $500 one or $1,000 one, you could develop it. And same thing for iOS. If you're going to build iOS, you kind of need a Mac in the process in order to, get it onto their store. So yeah, there are still things that need to be done, but you can use this to build once, and then you're just dealing with deployment pieces. So you can go through here and explore what Microsoft's documentation is on what they're doing, but it's some really neat stuff. So there are some things that are good to understand about the structure of .NET in order to better use it. And one of the things is this thing called the Common Language Runtime, the CLR. So to understand what the CLR is, it's useful to understand that we're going to write source code. We're used to that. We did that in C++. Just like C++, we write code as text files. Then now, when you built a C++ application, when you compiled it, it compiled it directly from, well, it compiled it from source code to a link file, and then it took that link file and compile it to native code. And that process is a little bit different with languages like C# and Java. One of the common things between Java and C# is they compile to an intermediary. In the case of Java, this bytecode. So in C#, they compile to IL, intermediate language. And then this intermediate language gets compiled to native code. The key here is that the source code compiles to IL. You distribute your application wherever it goes. When your C# application runs for the first time, it compiles to the native code for the machine that it's on using something called just-in-time compilation. And what that means is that they can optimize the code for the machine that it's on. So actually, when it compiles, if it compiles on my machine, it may not compile exactly the same as it is on your machine. It will actually customize itself to the machine that it's on. The upshot of that is that the first time you run a C# application, it takes a little bit longer because there's this last little bit of compilation. And then when it runs, from then on, it's actually faster because it's actually optimized for that machine. Pretty cool? I think it's really cool. So IL is very similar to Java bytecode. It's a low-level language with a simple syntax. Whenever you're reading computer stuff, anyone notice the word simple is kind of, it depends on your perspective. Yeah, well, we'll say a rudimentary or a pretty fundamental syntax, but it uses numeric codes rather than text. So it's a numeric type of programming language because it's not really meant for you to write in. It's meant for machines to quickly translate .NET code into native machine code. How many people want to bet that people actually try to learn a code directly in IL? Actually, there are people that just for fun try to figure out how to write IL code directly. Not that it's a good idea, just that it's, programmers will do anything. Some of the upshot of this is that it provides us some neat capabilities, notably with platform independence. .NET programs are compiled to IL, and since IL is compiled later to the code specific for a platform, it makes it a lot easier to actually make it so that we can run C# code on a lot of different platforms. And you're going to see, especially with the latest things that Microsoft is doing, that, that's why we can have MAUI and we can build our application once and it can be deployed to Android, iOS, PC, or whatever we want, Mac, because of this aspect of .NET. So IL is just-in-time compiled. You're going to see that term used a lot in a lot of different languages. If you've ever so you could argue that Python actually now is a just-in-time compiler, because what they do is when you run it, now Python is not partially compiled to an IL. It lives as its original text form, but when you run it, it compiles it at that point in time. So it used to be called an interpreter. I actually think it's justifiably considered a just-in-time language now because it compiles at runtime and it actually saves that compilation and each subsequent time it runs. So it's got that feature that's very similar to what IL does, other than it takes a little longer for it to compile on the first run because it goes all the way from its text code all the way to native code, unlike Java and C#, which compile to a intermediate stage, either bytecode or IL, and then at the last minute compile to native code. Languages are in competition with each other, and they learn from each other, and they adopted each other's capabilities, and so they all become better, actually, in many instances. JIT compilers will only compile a piece of code one time, and then they store the compiled version of the code. In addition, the JIT compiler optimizes the code for the machine's processor the code is running on, so that's really neat. And you can't really do this if you compile directly to machine code right off the bat, because if for example, when I compile C++, I'll be compiling it directly to an executable. Well, that executable could be optimized for my machine, but there's no point in it because you don't, if you optimize it for my machine, it may not work well, may not be a good optimization on another machine. So with languages that compile directly to native code, generally speaking, they just kind of pick a common solution. Now, there are optimizations they can do in the way they implement things so that at runtime, the code can actually optimize at that point, but that inflates the size and is not maybe quite as elegant as a JIT compiler. So, everything's got its advantages and disadvantages. So one of the things that IL gives us is language interoperability. And what does that mean? Well, essentially, it means that if you are a .NET language, you use IL, and if you use IL, that means you get this behavior. So, and actually, this one, I think it actually, I don't know if it's every version of C++ with, I have to see how this works with C++. I think C++ compiles directly to there, but I think there's ways of doing it so that it compiles to IL. But C#, Visual Basic, F#, most of the .NET languages compile to IL, and this introduces other features which are really nice. Intermediate language is an object-oriented language, and it also uses these things called interfaces we're going to learn about. There's a strong distinction between value and reference types in IL. There's strong data typing. It has error handling using exceptions built in, and the use of something called attributes, which we'll actually learn more about in .NET 2. It's not compiling down to a super primitive language. When you compile down to IL, it's got support for objects and object-oriented programming, so it makes IL compilers for all those languages. Now, one of the neat things with .NET is that you can actually make a project with multiple languages. So if maybe you like using the interfaces that are available, like MAUI and or WPF or some other kind of GUI application, and that's written primarily in C#. So you could write that in C#, but then maybe there's some libraries in C++ you want to use. Well, what you can do is you can actually create projects in multiple languages, and because they compile to IL, they can see each other's objects. They can see each other's classes, and you can actually, so you could use a C++ class in a C# project. And as long as it's a .NET language, they can talk back and forth to each other. If you like F#, you like functional programming, but you don't want to use it for everything, you could use functional programming to solve certain problems, and then object-oriented C# for other problems. You can, I think it's R and Python. You can write some stuff in Python and other stuff in C#. So you can mix and match languages by just including multiple projects in your solution. Pretty cool. So IL makes a strong distinction between value and reference types. Anybody remember value and reference types from C++1? So like an int, is an int generally a value type or a reference type? Yeah, it's a value type, right? When you, and how can you kind of think of this? Well, if you pass an integer to a function, do you get a pointer to that integer, or do you get an actual copy of the value of the integer? You get the copy of the value, right? So that implies that it's a value type. If, on the other hand, when you pass the variable name to a function, you end up with a pointer, an address, well, then it's a reference type. And so these principles apply in C# and in Java and even in Python, except that whereas in C#, you will be working with the pointers directly. In C++, you work with the pointers directly. In C#, we don't. You can, it's called unsafe code, but in order to avoid some of the possible errors you can get by, going outside of your memory space, uh, in C#, they say, you know what, we will provide you mechanisms to work with pointers that are underneath, and so you do not work with pointers directly in C#. Anyone sad about um, having to figure out where to put asterisks and ampersand signs all over the place? I mean, it's a lot of fun, but yeah, you won't have to do that. Instead, we're going to use the ref and out keywords, and thanks. Um, and uh, uh, and it and so we will work with those indirectly. But here's the thing: be really glad that you took C++1 and you went through all that, and and try to keep hold of that understanding of how pointers and references work. Make yourself a C++ program every once in a while where you have to deal with that, because that gives you a certain understanding of what's happening below, at a lower level, that you wouldn't get if you just were completely in a more abstracted language like Java or C# from the beginning. So that's probably one of the most valuable things you got out of 1275, and it's probably one of the more painful ones, was dealing with pointers and references. But and so if you got that at that point in time, it really made sense. Great. If you're still working on getting an understanding of that, keep working on it, and learn to understand it. Maybe go look some videos up and work on some programs. Maybe go back and review those programs. It's well worth it to really kind of understand what's happening with pointers and references. And that knowledge will affect how things work, because you will have value types and you will have reference types. And it does mean that some things will come into functions as indirectly, and when you modify them in the function, it will modify them also where they came from, and other things will come in as value types, and that means if you modify them, they won't modify the original. So knowing pointers and references allows you to understand when that happens. Strong data typing. IL is strongly typed. All variables are clearly marked as being a particular type. It does not permit operations that result in ambiguous data types. So that could seem painful, but what's the benefit of having a strongly typed language? Any ideas? Yeah, I would say actually maintenance of your code. You know, anyone remember the Ariane mishap? Does anyone remember seeing that in C++1? The Ariane rocket? What happened with the Ariane rocket? What was the thing that made it flip 90 degrees at Mach 6 and explode in the sky? But basically, they're passing, I believe it was a double floating point, a double number into a function that took a floating point parameter. What would be the issue with passing a double to a floating point number? Welcome, Brad. Yeah, so let's
Thank you.
see. Yeah, we're talking about floating point numbers and doubles. So double versus floating point. Oh, now we have AI that's going to step in and tell us about this. Let's see what that says. So it says a 32-point number, which means it occupies 4 bytes of memory, and 64-bit number, 15 decimal points. And so really what we're thinking about is magnitude, right? Um, and it may have been maybe it was a double and a float, maybe it was a float and whatever's smaller than a float. But basically what it was is if you looked at the magnitude of a floating point number, um, yeah, a double can represent 16 digits of precision. A float can only do 7 digits of precision. And um, and so what happened was is as soon as you went to a number that needed one more binary bit than this, it actually causes the number to flip. And so it goes from positive to negative. So imagine yeah, exactly. Imagine you're going at Mach 6 and suddenly it doesn't think it's going Mach 6 in the north direction. It thinks it's going Mach 6 in the opposite direction. Well, what's it going to do? It's going to say, hey, let's turn 90 degrees or let's turn 180 degrees because we're going in the wrong direction. Well, it tried to turn 180 degrees and all at once, right when that bit flip happened, and at Mach 6, no rocket in the world can withstand that, and so it exploded. So that was basically just a type error. Yeah, because they used the wrong type. That's it. And several cajillion dollars later, and it's really cool watching that video because you see all those engineers in the control room, just their face just goes uh, slack, and they're just staring at the screen with their mouth open. Um, and it's a simple error. So languages like Java and C# will actually do a lot more type checking than even C++. C++ actually, that was written in C++, doesn't do, it's a strongly typed language, but it's not that strictly, it's not, arguably you could say there's also, really strictly typed languages. C# and Java generally are very strict about their typing. If you try to do that, it's going to throw an error or at the very least a warning. I think it throws an error. We'll take a look possibly and see if it does it. So if they wrote it in C# or Java, probably would have been safer. Um, and that's one of the advantages of these languages when they're .NET is IL is strongly typed. You want as much strongly typing as possible when you want super maintainable code. So one of the themes you're going to see here is as we start working with C# and .NET, we're really talking about developing code for a lot of enterprise applications, uh, big businesses where they want stuff to be stable. So, you're there's always these discussions of what's the best language. Well, it just depends. If you're doing laboratory stuff or you're doing AI and you're doing a lot of things where you're going to create the code one time, you're going to get a product out of it, and then you're going to pretty much throw away the code, you want a language like Python. But if you're going to be making something that needs to be maintained and it needs to stay stable for maybe years and years and years and years, then you're going to want C# or Java or something else, which is a nice stable language. Yeah, so advantages of type safety. Well, the other nice thing about having a strongly typed language is that that's also what enables .NET languages to work interoperably with each other, because we can define if you can just kind of throw things all over the place, it's a little harder to translate code from one language to another if the type is strongly typed, it's a little easier to translate from one language to the other. We're going to see there's also garbage collection. If you are in C++2 or you've had C++2, should you use the new keyword all the time? Every chance you get, just new everything up. Generally, no. With C++, every time you use a new keyword, you have to take responsibility for making sure that gets destroyed. So you have to do a lot of memory allocation and tracking. With C#, you don't have to worry about it. With Java, you don't have to worry about it. With Python, you don't have to worry about it. They have garbage collectors. And so as soon as a variable is no longer referenced, and that means, as soon as it drops out of one of your blocks, things wrapped in curly braces, and it's no longer accessible, what C# and what languages that have garbage collection do is they put those variables on something called the garbage heap. And they don't deallocate them right away. They only deallocate variables when memory is needed. So with a small program, actually, they may not garbage collect it or deallocate it until the program's done. But with bigger programs, then they may do it, much more frequently. But the nice thing is that they only garbage collect when they absolutely need to, which is probably more efficient, because if you deallocate right away each time, well, there may be deallocations you do that you don't really need to do. So, and that gets taken care of for you. Again, this is a feature that makes it a little easier to write maintainable code, because one of the most common problems with C++ is, of course, a memory leak issue. Now, they've got a whole bunch of new things in C++, which makes that not a valid argument to not go for C++. It's just that you have to apply more discipline when you're writing C++ code to do it correctly. You have a lower chance of making that mistake with a language like C# or Java. Also, another advantage of type safety and security is by making sure that you're not writing outside of the right zone. It's harder to do to engineer a Stack Overflow in languages which have a lot of type safety, and application domains. I don't know if that's so much of an issue anymore, but in any case, there's things that's a pretty esoteric discussion about how applications run in the at the lowest level. So the nice thing about so we have strong typing, which gives us a lot of interoperability. And so what you end up with is something called the common type system. So we have, we talked about the CLR, the common language runtime. The common language runtime makes use of something called the common type system, because, in C++ you have, you have integer, and C# you have int, and other languages you may have other ways of specifying, the idea of an integer. So IL says, okay, we have something called IL int 32. And they map the C++ integer type to IL int 32, and they map the C# integer type to IL int 32, and the F# version and everyone else's version gets mapped to this. So basically they have this big translation table of types across all the different languages. And let's see, can I do this without breaking it? Yes, I can. Victory. So, and it follows this object-oriented inheritance structure. So at the top, you have the type system, and then they split off into value types and reference types. And your value types, you have built-in types. That's like your integer and your float and all those types of things. Enumerations, which we'll look at later, and user-defined value types, which are really your structs. So those are structs. And then you have reference types, which includes pointers, which we generally don't use directly, self-describing types, which include arrays and classes. And then classes, you have delegates, user-defined, and box value. We're going to learn about delegates and user-defined types. In fact, the primary thing we do when we're writing C# code is we define classes. So this is actually where we're going to spend most of our time. So, but we're also going to create delegates, which we'll see later. And then you have interfaces. We're going to learn also about interfaces as well. So that's the structure of the common type system. This spiders out into a whole bunch of more stuff, but that's the top level of it. And then we have the common language runtime, the CLR. We have the common type system, and then we have the common language specification. And that's basically a spec to ensure that all the .NET languages have to comply with in order for them to be able to be a .NET language. So it's a standard. So garbage collection, yeah. So I already spoke about garbage collection, but basically some languages do not have automatic garbage collection like C++. That can lead to memory leaks. So you have to be good at deallocating unused memory and understand the proper way of coding with C++ to prevent that. C# allows us to be lazy in that regard. We can just use a new keyword all over the place, and C# will clean up for us. Assemblies. There's another concept that we need to know. Assemblies basically are, they really correspond to the project that we're going to see that we're going to have a solution, and we will have one or more projects under the solution. The project, when you build it, builds into something called an assembly. So your program overall is itself an assembly. If you have any libraries, those are also assemblies. So it's good to know that the term assembly is really referring to either the library or the program that's in a project. We're also going to see this term namespace. So a namespace is really, it's actually pretty self-describing. A namespace is, you'll see at the top of our code, we're going to see this thing says namespace, and typically it's just one name, but you can actually have namespaces be name.name.name. And at one point, the recommendation from Microsoft is that it actually was kind of like your the domain name for your website or your business, com dot whatever your business was, whatever your product was, and you did that and the whole idea was to deconflict when your library was brought in with another person's library. It was to try to deconflict the names that were used. I don't know that that's happening, but we do invariably. The namespaces generally default to the name of the project they're in and the folder structure that you're in. So you'll see, like, if you were to make multiple folders in your project, you'll see that folder structure show up as the default namespace on here. You can change it to whatever you want. I would generally stick with the default scheme. So it would be the project name, and then and then a dot with every folder name that follows it. It makes sense. And then we're going to see that everything's going to be a class in C#. So we're going to have a class name and then our method names. And this is actually what your main program, notice that main is capitalized in C# and C++ it was lowercase, but in all other respects, it's very similar. So that was basically, an introduction to C#, a basic understanding of how the .NET ecosystem comes together. It's the fact where I think the strongest aspects of .NET are that you can build anything, and it's exciting that you can have one language and you can build PC apps, Android apps, iOS apps, games, 3D games, HoloLens headsets, whatever. There's a way of building it with C#. So it's an extremely versatile language at this point.